Okay, inertia. So let's let me give you few examples, then we can we can discuss what is inertia. Okay, in case of suppose maybe you have seen 100-meter race, in which there are a lot of like 6 to 7 runners run through 100-meter race. Okay, suppose this is finishing line, and there are runners. Suppose one, this is runner number 1, runner number 2, runner number 3, and so on. Okay, like you have seen when these runner run through 100-meter race or 200-meter race, whatever the race size of race is, like you may have come across that when these runners run through this platform, suppose, but when they reach the when they will reach the finishing line, they are unable to stop themselves at the same position. Like here, like suppose this is the finishing line, it is difficult for them to stop themselves here, but they will continue their motion and will stop somewhere away from the finishing line. What is the reason behind it? Like this is the finishing line, and they stop themselves like maybe 20 meters away, 30 meters away, 40 meters away from the finishing line. Okay, there is one more example. So like assume that suppose here is a fan. Just assume that it's a fan. Okay, the fan is the feathers of the fan are rotating continuously. If you switch on the switch on or switch off, then there is no electrical energy, there is no electricity, there is no current, but still the feathers of this fan continuously rotate for some time continuously, and then after some time these will stop. Why don't they they stop at the same time when you switch off? Why the runners don't stop themselves at this finishing line, or some few centimeter, few meters away, like somewhere here, like this is the finishing line. You were supposed to run till here, not like 50 meters away from this line. So this is the finishing line. Why don't they stop here? Why the feathers of the fan continuously rotate after like when you switch off, they continuously rotate, and after some time they stop? The reason is called inertia. The reason is called inertia, and inertia means it's like inertia, like one second. The runner could not stop himself here because of its mass. The fan will not stop itself at the same time because of its mass. So due to mass, every object will gain a natural reluctance or resistance. That reluctance or resistance is called inertia. So due to mass, how do we define it? Due to mass, every object will object will have a reluctance, or you can say resistance. Every object will have a resistance or reluctance, and this is due to mass. Reluctance for what? For reluctance against change in state. Now, which state? Rest. Oh, sorry. Rest or motion. Okay, now let's split it into parts and then we will discuss it one by one. Okay, like the runner will have some mass, and due to its mass, like you can see, due to mass the runner have some mass, and due to its mass the runner will have a reluctance or resistance. For what? Against change in its state. It has two states. The object can have two states, either the object is in state of rest or state of motion. But in case of runner, the runner is in state of motion, and the runner will resist against change in its state of motion. Like the runner does not stop here because of its mass. It resists, it show reluctance to stop here due to its mass. Due to its mass, this reluctance is called inertia. Similarly, fan will not stop at the same moment due to its mass. That reluctance is called its inertia.